Hello, and welcome to The Space Above Us. Supplemental 6, Rogers Commission Testimony of Allan McDonald. Before we get started, I want to give a quick warning to anyone who just automatically queued this up and is driving or something. This supplemental is quite a bit longer than usual, coming in at over an hour and a half. I think it's pretty interesting, but when a friend of mine balked at the extreme length, I figured it'd be good to give people a heads up in case they wanted to skip to whatever's next in their queue. No hard feelings. The intent of the supplementals is to be a parallel track to the main episodes that is not necessarily required to match up one-to-one. This way, if I want to revisit a topic or go into more depth about something from a main episode, I have a built-in mechanism to do that. It's a little bit confusing since I put them in the same feed as the main show to save everyone from signing up for two feeds, but so far it's worked out. I only mention this so that if you are actually listening to the supplementals disconnected from the main episodes, I strongly suggest that before listening to this supplemental, you should listen to my coverage of the Challenger accident, which is in episodes 92, 93, and 94. One of the defining moments associated with the Challenger accident was the fateful teleconference between engineers and managers at NASA's Marshall Space Flight Center and Morton Thiokol Incorporated, the manufacturer of the shuttle's solid rocket boosters. We covered this meeting in depth in episode 94, where we learned that Morton Thiokol initially recommended against launching Challenger in such low temperatures. Several NASA managers pushed back, questioning the logic used to arrive at that recommendation, a complete reversal of the typical relationship between NASA and contractors. Rather than being asked to prove that their product was safe, Morton Thiokol was being asked to prove that it was not safe. Managers at Thiokol, under what they perceived as pressure from NASA, reversed their initial recommendation, and instead said that the SRBs on STS-51L should work no differently than on STS-51C. As we know, this led to the tragic loss of both the Challenger and its crew. But part of how we know this is because during the investigations of the Presidential Commission tasked with determining what happened, someone heard something that he knew to be wrong, put his career on the line, and stood up to say something. That someone was Morton Thiokol's director of the solid rocket motor project, Allan McDonald. His surprise contribution to the proceedings are the first the commission heard that Morton Thiokol had initially recommended against the launch. Would we know as much about the Challenger accident if Allan McDonald had not stood up? Maybe. The Rogers Commission was full of very smart, very focused people who knew how to get to the bottom of a complicated problem. So it's entirely possible that they would have figured it out eventually some other way. But we'll never know, because he did, which was a pretty gutsy thing to do. McDonald went on to formally testify in front of the commission in 2 hearings. And since one of them was public, that means that we have actual audio and video of his testimony, not just transcripts. What we'll be hearing today is the entirety of McDonald's testimony on February 25th, 1986, less than a month after the accident. It's pretty long, but I found it to be riveting. Also, a couple of times the audio dropped out for a few seconds, so I just cut those sections out. Before we play it, I want to say thanks to C-SPAN, where I got this audio. I believe that since this hearing was part of a presidential commission, since I probably count as an educational podcast, and since I paid $1 for the MP3, it should be fine to share with all of you. I'll be sure to include a link to the full video in the announcement tweet for this episode, and the show notes, which still don't exist but someday will. Since McDonald testifies first, I just left the opening few minutes of the hearing intact, so you can hear how something like this gets started. The first voice you'll hear is that of the Commission's chairman, William Rogers. You'll also hear questions from other members of the Commission, including Neil Armstrong, Sally Ride, and Richard Feynman, among others. Alright, I've talked enough. Let's listen to what Allan McDonald has to say.
In our sessions today and tomorrow, we want to present in a thoughtful and orderly manner the facts relating to the decision to launch the Challenger. Because of its importance, I will ask witnesses to identify the time and place of any event that they are addressing and the names and positions of persons who participated. The Commission wants to be fair in the presentation of the facts. Because the subject matter may involve possible human error as distinguished from equipment failure, the Commission will attempt to give a right of reply as soon as possible to any person who believes he has been unfairly criticized or whose actions may have been inaccurately portrayed. During the last 2 weeks, the Commission has encouraged NASA to disclose a large number of facts and documents relating to the launch, which has been done. As a result, we believe the public is better able to understand and assess many aspects of the accident. We hope that this process will continue until all the facts are fully known and, as much as possible, fully understood. While the Commission has the responsibility under its mandate from the President to investigate the accident and report its findings, the media plays a key role in the process by keeping the public informed. We believe it has performed this role well and with a high sense of responsibility. If the Commission effectively performs its duties and the media performs its role of accurately reporting the facts as they develop, the public will be well served. Witnesses who appear today will be able to comment or to clarify their testimony as long as the substance, comment on or clarify their testimony as long as the substance is not altered. Of course, any additional evidence or additional material that might assist the Commission in the performance of its duties and responsibilities will be welcome. The first witnesses this morning will be Allan McDonald. Following Mr. McDonald and at the request of Morton Thiokol, the Commission will next hear Jerry Mason, who is Executive Vice President of Thiokol. First, I would like to call upon our Executive Director, Dr. Keel, who will make a few comments before we hear Mr. McDonald.
Mr. Chairman, for the benefit of the Commission, we have put together a chronology of events relating to the period when the first temperature concerns were raised with respect to the Challenger, indicating the activities and also the participants as the Commission understands them based on testimony and documentation provided to the Commission. This chronology has been provided to all the witnesses, Mr. Chairman, so that they'll have an opportunity to understand our reconstruction of those events and to clarify them, and also to, as appropriate, to identify the nature of the discussions at each of these meetings and activities, starting approximately from the scrub of the originally planned launch of Challenger for January 27th at 9:38 a.m., ranging up to the launch of the Challenger on January 28th at 11:38 a.m.
And if there are corrections that have to be made on this document, we'll make them as we go along. It's as accurate as we can make it at the present time. Now I'd like to call on Mr. McDonald, please. Yes. Mr. McDonald, I think if you take the middle chair, it might be best. I think to be consistent, let's swear all the witnesses in again. Some have been sworn and some have not, so let's swear them all again, please.
You swear the testimony you give before this Commission is the truth, the whole truth, and nothing but the truth shall be done. I do.
Mr. McDonald, you're now employed by Morton Thiokol, Inc.?
That's correct.
And how long have you been employed by them?
I've been with Morton Thiokol for a little over 26 years.
And you're an engineer?
Yes, I have a bachelor's degree in chemical engineering from Montana State University and a master's degree in engineering administration from the University of Utah.
And can you give us some history of your employment with Thiokol?
I'm currently the director of the Space Shuttle Solid Rocket Motor Project. My responsibilities are for technical cost and schedule performance of the steel case motors that are flown out of Kennedy, and also the development qualification of the film and wound case solid rocket motor to be flown out of Vandenberg Air Force Base. I've had this position for a little less than 2 years. I started as director in March of 1984 of the Shuttle SRM project. Prior to that, I was the manager of the project engineering division at Morton Thiokol, which I had technical responsibility from a project engineering standpoint for all of the programs in the plant, with the exception of the space shuttle. That included the Peacekeeper, the MX Stage 1, Trident 1 C4 production, Trident 2 development, the HARM, Mark 104 standard missile, PAM-D2, the improved performance space motor 2, finished a contract on qualification of a long life motor for SRAM. I had all of the independent research and development, advanced technology programs with the Rocket Propulsion Laboratory, and also some work on airbag air cushion restraint systems. I had that job, I guess, for about 3-4 years prior to coming into the shuttle program, and prior to that I was the manager of the propellant development department for a few years, and prior to that I was the manager of the project engineering group for advanced development and development projects. I started with IACOL in '59 after graduating from Montana State University, and my first job was involved in designing the external insulation for the Stage 1 of the Minuteman. I did that design, and I was then chosen as a group leader for flight test of the Minuteman, and was participated in the flight test about the first 20 flights of the Minuteman out of the Cape. Subsequent to that, I spent considerable time working as a chief engineer on development of some controllable solid rocket motor concepts for several years, and worked on a lot of advanced development programs before I came involved in the Trident program in the early 70s.
For the last 3 or 4 years, where have you spent your time?
The last couple of years, of course, I've spent my time as director of the Solid Rocket Motor Project, which involves a considerable amount of coordination relative to production of the shuttle solid rocket motors, assessment of the flight readiness reviews for the Space Shuttle solid rocket motors. I am the chairman of the Senior Material Review Board for the SRM. That Senior Material Review Board has to review all of the discrepancies on any of the hardware that's considered a Criticality 1 or any that's outside the experience base of our previous experience. As chairman of that board, there's members from our quality group, our engineering group, NASA Marshall representatives, but I have to sign every one of those that they're ready for flight. I'm also a co-chairman of a problem review board with Marshall Space Flight Center relative to any problems that are identified from returned hardware that come back to the Cape, and what actions are taken to understand those problems and provide proper fixes for those and prevent them from occurring. My activities in the past year, to a large extent, have been involved with design certification of the filament wound case solid rocket motor. I'm also the co-chairman of the design certification team represented by Thiokol and Marshall at the SRM level for that, and that has taken a considerable amount of my time this past summer in a series of reviews for certifying the graphite composite case for Vandenberg.
Now, how much time did you spend in the performance of those duties at Kennedy Space Center?
Well, I have been alternating with my supervisor, the Vice President of Space Booster Programs, Mr. Joe Kilminster, on the... Joe Kilminster.
And what is his title?
He's the Vice President of the Space Booster Programs. And he and I have been alternating going to the Cape, supporting the launches of the SRMs. It's a very busy...
Your immediate supervisor?
He's my immediate supervisor, yes.
And you alternated going to the Cape?
Yes.
Now, how did that work?
That works out fairly well. We both, of course, have a fairly heavy demand on our time with all the reviews in the shuttle process, primarily with the trips to Huntsville and the Marshall Space Flight Center. I attended, of course, the STS-51L. He was at the prior flight, and our charter is to attend the L-1 meeting.
F-51L is the Challenger launch.
That's correct.
And you were there at that time. Was he, Mr. Kilminster, there the previous launch?
He was at the previous launch, yes.
What about the one before that?
One before that I was at. And he was the one, I think, before that. We've been fairly well alternating.
And what were your responsibilities when you were there at the Cape at the time of the launch?
Well, at the time of the launch, I was in the firing room, too, Launch Control Center. There's seats there that for the monitors of many of the functions on the solid rocket boosters, as well as the TV monitor. The Marshall Space Flight Center has a group at their console that involves the primary contractors for all of the subsystems. The SRB has one monitor, and they have people from USBI who provide part of the hardware for the SRB and for the shuttle. We also have a monitor from our support to the Space Shuttle processing contractor that is right next to that monitor, and Mr. Carver Kennedy, our Vice President of our space operations at the Cape, was at that monitor. It's right next to the Marshall monitor, and I was sitting with him at the time of the launch.
I wasn't speaking so much about the Challenger launch as I was generally speaking. Generally speaking, when you or Mr. Kilmaster are at Kennedy, you speak for the company, is that it?
Yes. Generally, the process is before a launch, there's an L-1 meeting the day before the launch, at which time all of the problems that were still open prior to the L-1 are reviewed with Jess Moore and his board, and assured that they're all closed out and we're ready for the launch. Subsequent to that meeting, there's a poll that is taken. He takes an oral poll of everyone that's involved in the launch, including as well as the propulsion systems, but the payload and everyone else. And every contractor that is involved in that has to answer to the poll as whether they're ready to go and launch. I attended that meeting. As you know, the L-1 meeting was conducted, I believe, on Saturday or something before.
If you don't mind, come to that in chronologically in just a moment. But so at those meetings, when you were there, you spoke for Thiokol.
Yes, I spoke for Thiokol.
And how long had you been there prior to the launch of the Challenger, physically located at Kennedy?
I was at Marshall Space Flight Center earlier in the week on some negotiations for our subsequent contract, and had went down to Kennedy on the, I believe it was the Thursday before the launch.
Could you give some explanation of the relationship between yourself and Marshall before you went to Kennedy?
I'm not sure what you mean by relationship.
Well, what function was Marshall performing at that time, and what were you doing in representing Thiokol?
Well, Marshall has overall responsibility for all of the propulsion subsystems on the shuttle, and we are part of the SRB team. I work directly with Larry Ware, who is the project manager for Marshall on the solid rocket motor, and he works for Larry Malloy, who is the project manager on the SRB, which includes the solid rocket motor and the aft skirt TVA system and the parachute recovery system. Makes up the whole SRB. And I always attend, or Joe Kilmister attends, the launches with Mr. Malloy, and he has the representatives also from the other subcontractors for USBI. In case there's any questions that come up that we can either resolve there or get resolution to prior to the launch.
Just for the record, where's Marshall located?
Marshall's located in Huntsville, Alabama.
And when did you leave Huntsville, Alabama to go to Cape Kennedy on this occasion?
Well, I think it was Wednesday or Thursday afternoon before the launch.
Did you go by yourself or with someone?
No, I went by myself.
Now, I want to give you an opportunity to give a full description of the events the day before, on the 27th, and the day of the launch. Before I do that, I understand that you made some notes after the accident, which put on paper some of your recollections of the events that preceded the accident. Is that correct?
That is correct.
And you have those notes now?
Yes, I have those notes.
I would like to explain to you that you're at liberty to refer to those notes in any way you want to. And now, beginning with the first recollection you have of the weather problem and how it came to your attention, give us a full account of the events of that day and the following day, 27th and 28th. We'll try not to interrupt you except possibly for clarification. I want you to feel free to tell everything you recall about it, and then after that we may ask some questions to try to amplify any answers that you may give.
Well, I first become aware of the concern of the low temperatures that were projected for the Cape was late in the afternoon on the 27th. I was at Carver Kennedy's house. He's the vice president of our, as I mentioned, Space Operations Center at the Cape, supports the stacking of the SRMs. And I had a call from Bob Ebling. He is the manager of our ignition system and final assembly, works for me, a program manager at Thiokol in Utah. And he called me and said that they had just received some word earlier that the weatherman was projecting temperatures as low as 18 degrees Fahrenheit sometime in the early morning hours of the 28th, and that they had some meetings with some of the engineering people, had some concerns about the O-rings getting to those kinds of temperatures. And he wanted to make me aware of that, and also wanted to get some more updated and better information on what the actual temperature history was going to be predicted, so that they could make some calculations on what they expected the real temperature the O-rings may see.
He was calling from Utah?
He was calling from Utah. I told him that I would get that temperature data for him and call him back. Carver Kennedy then, when I hung up, called the Launch Operations Center to get the predicted temperatures from Pad B, as well as what the temperature history had been during the day up until that time.
And Pad B was the area where the launch was going to
Pad B was the pad that the Challenger was to fly off of, and this was the first time that it would fly off of that pad. He obtained those temperatures from the Launch Operations Center, and they basically said that they felt it was going to get near freezing or freezing before midnight. Could get as low as 22 degrees as a minimum in the early morning hours, probably around 6 o'clock. And that they were predicting a temperature of about 26 degrees at the intended launch time, about 9:38 the next morning. I took that data and called back to the plant, sent it to Bob Ebling, and relayed that to him and told him he ought to use this temperature data for his predictions, and that I thought this was very serious, and make sure that he had the vice president of engineering involved in this and all of his people, that I wanted them to put together some calculations and a presentation material.
Who was the vice president of operations?
Mr. Bob Lund is our vice president of engineering at our Martin Thiokol facility in Utah, to make sure that he was involved in this, and that this decision should be an engineering decision, not a program management decision. And I told him that I would like him to make sure they prepared some charts and were in a position to recommend a launch temperature. Just don't recommend a launch, but recommend a launch temperature, and have the rationale for supporting that launch temperature. I then hung up and I called Mr. Malloy. He was staying at the Holiday Inn in Merritt Island, and they couldn't reach him. So I called Cecil Houston. Cecil Houston is the resident manager for the Marshall Space Flight Center office at KSC, and told him about our concerns with the low temperatures and the potential problem with the O-rings. And he said that he would set up a teleconference. He had a 4-wire system next to his office. His office is right across from the VAB in the Trailer Complex C over there. And that he would set up a 4-wire teleconference involving the engineering people at the Marshall Space Flight Center at Huntsville, our people back at Thiokol in Utah, and that I should come down to his office and participate at Kennedy from there. And that he would get back with me and let me know when that time would be. I waited for a short period of time. I don't know exactly how long. It wasn't very long. He called back, told me that he had contacted the parties and it was all set up for 8:15 p.m. Eastern Time for that teleconference. I relayed that message on back to the plant, told them that we have to have charts at that time faxed out to Kennedy as well as Marshall that we could discuss for that teleconference.
Could you explain what charts mean?
Well, they're charts, any data that we had for showing why we had concerns on the O-rings at low temperatures, what our history has been, what any calculations that we might be able to make relative to their performance, supporting it, rationale for what is an acceptable temperature, what might not be an acceptable temperature, and to review that. And these would all be on charts that we would send by a fax machine so that people could read those and we could discuss those as the rationale for either recommending a launch or not. I arrived at the Kennedy Space Center at about 8:15, and when I arrived there at the Kennedy Space Center, the other people that already had arrived were Larry Malloy was there. He is the manager of the project manager for the SRB for Marshall. Stan Reinhardt was there, and he is the manager of the shuttle project office. He's Larry Malloy's boss. Cecil Houston was there, the resident manager for Marshall. And Jack Buchanan was there. He happens to be our manager, Morton Thackal's manager of our Launch Support Services office at Kennedy. The telecon hadn't started yet. It came on the network shortly after I got there, but was told to hold on because the charts had not been received either at Marshall or Kennedy at that time. And we waited, I guess, for probably another half hour before those charts finally came through and we could reproduce them. In fact, they hadn't all even been received yet. There were some conclusion recommendation charts didn't come for about a half hour even later than that. But
was it essentially a telephone conference, or was there actually a network with pictures?
It was a telephone conference, just telephone. You could hear the voices from the other two places as well as your own. However, the way those teleconferences work, there's buttons that you can push and will mute out you speaking. If someone else is speaking, you can usually hear it better when you don't have your own mics open. So there's a lot of conversations, I'm sure, at all the facilities at one time which you can't hear, but I'll relay on what I had heard on the conference as best I can. The teleconference started, I guess, close to 9 o'clock. And even though all the charts weren't there, we were told to begin and that Morton Thackall should take the lead and go through the charts that they had sent to both centers. The charts were presented by the engineering people from Thackall. In fact, by the people that had made those particular charts. Some of them were typed, some of them were handwritten. And they discussed their concerns with the low temperatures relative to the possible effects on the O-rings, primarily the timing function to seal the O-rings. They presented history of some of the data that we had accumulated both in static tests and as flight tests relative to temperatures and performance of the O-rings. They reviewed the history of all of our erosion with any O-rings in the field joints, any blow by the primary O-ring with soot or products of combustion or decomposition that we had noted, and the performance of the secondary O-rings. And there was an exchange amongst the technical people on that data as what it meant and discussions. But the real exchange never really came until the conclusions and recommendations came in. At that point in time, our Vice President, Mr. Bob Lund, presented those charts. And he presented the charts on the conclusions and recommendations, and the bottom line was that the engineering people would not recommend a launch below 53 degrees Fahrenheit. The basis for that recommendation was primarily our concern with a launch that had occurred about a year earlier in January of '85. I believe it was 51C, was our motor number SRM-15. And that particular motor had a couple of field joints that not only had some erosion, but they had some fairly severe blow-by. The primary seals, fairly heavy soot over a fairly large arc, very deep and black. And even though we could see no measurable erosion on the secondary O-ring, there was a heat effect. And by that, the sheen was gone off of the O-ring seal. It wasn't, you couldn't measure anything, but the sheen was gone. And because of that, we were concerned of launching beyond our experience base below that temperature. Well, that temperature brought a lot of strong comments and reaction from several of the NASA officials. I believe it was Mr. Malloy made some comments about when we'll ever fly if we have to live to that. sometime in the future, and also commented that we are trying to establish new launch commit criteria. We can't do that. You don't do that the night before a launch. That's a predetermined set of constraints, and we can't do that. And other comments were made about whether we could ever fly out of Vandenberg and 24 flights a year, because it wasn't uncommon to have 53 degrees in the early morning hours where a lot of the launches occur. One of the comments that came, and this was by voice recognition, I believe it was from Mr. Hardy at Marshall Space Flight Center, was that he was appalled at that recommendation. However, he also said that he certainly wouldn't fly without Thiokol's concurrence. He would not fly without Thiokol's concurrence, even though he was appalled at that recommendation. I believe it was Stan Reinhardt's made a comment that he was under the impression that the solid rocket motors were qualified from 40 to 90 degrees, and that 53-degree recommendation certainly was inconsistent with that. Someplace in the conversation about the impact of 53 degrees, I believe Cecil Houston at some time commented that, it wouldn't be till about Thursday that we would have morning temperatures probably in the 50s. So he didn't seem to be as alarmed about when, we could get to that temperature. There were several challenges relative to what was felt, how conclusive the effective temperature was on this whole problem of O-ring erosion or soot blow-by. And the challenge came from looking at the total data, because even though we were as concerned about this flight, which was the coldest ever at that time from Florida, a year earlier, there was a flight back in the late fall of '85, I think it was probably October, 61A, it was our SRM-22 set, that had some blow-by the O-rings. No erosion of the primary O-rings. In fact, a couple of them, I believe. And this happened to be a launch that had the highest temperature. So there was some concern that the data was inconclusive. And also that we had some motors that were static tested as low as 36 degrees Fahrenheit, DM4, I believe, and it showed not only no O-ring erosion but no blow-by. Well, some of the comments that came back from that, and I believe it was Roger Beaujolais commented that he felt that there was a significant difference in the observation of the actual soot that passed the primary O-ring on the SRM-15 set that was the cold one versus the one that was warm. That there was a much larger arc between the two O-rings that was affected with soot, was much blacker. It penetrated all the way up to the secondary O-ring, and of course we had some heat effect there, and he thought there was a significant difference, and that well could be the difference just due to temperature. I commented at that time about the static test history. I told him I did not feel that that was a valid data for a couple of reasons. One, on the static test motors, we keep the static test motors in a environmental building, essentially, during the build-up, assembly, and checkout of all the instrumentation. And that environmental building is kept at 70 to 72 degrees. That building is then rolled back on a track about 6 hours before the static test, so it wasn't exposed very long to the cold temperatures. And secondly, in the static test motors, we went in and actually repaired and filled holes in the putty. These holes are formed by the assembly of the rocket motor. As you form the tang and clevis, there's air trapped in there. That air's got to go someplace, and sometimes that air will go up through the putty. We have seen this, and also when you run the leak check on the two seals, if you get any blow-by during the leak check, it may tend to propagate those. And in the static test motors, some of these were observed, and they went in and filled those inside the motor prior to static test. So I told them I didn't feel that that data was conclusive, and they shouldn't use that for deciding what the O-ring performance was. At that time, there was other discussion on some of the charts that we had that was somewhat inconclusive. We had a chart that had some subscale data where we had run some tests on blow-by with some subscale O-rings. They actually had the full-scale diameter, 280 thousandths, but they were smaller. That was the cross-section of the O-ring, but they were smaller diameter hardware. and they were coal gas tests, and we were attempting to try to measure what kind of blow-by one might get with the pressurization rates you see in the motor, and we were using argon as the working fluid, and also I think some Freon, and we had run tests at around ambient 30 degrees in those and did not see any difference. So there was some conflicting data there. It said that it wouldn't make any difference, but that, I want to remind everyone, was a coal test. At that time I commented at the time that I felt that lower temperatures were in the direction of badness for both O-rings because it slows down the timing function for both of those, but the effect is much worse for the primary O-ring compared to the secondary O-ring because the leak check forces the primary O-ring in the wrong side of the O-ring groove while it forces the primary O-ring in the proper direction. This fact should be weighed and considered in making an evaluation as to what the recommended temperature should be. I was looking at a chart at that time that we had. In fact, it's a chart that I had made with some help of our engineering people back last summer in a presentation I had made here in Washington to headquarters people in August 19. There was a chart that showed that there's really three phases or three regions of concern and during the ignition transient relative to the performance of the O-ring. First phase of that is a condition where the O-ring, the primary O-ring, is pressurized. It starts its energizing process and actually has to move from the forward face of the O-ring groove because that's where it's at as a result of leak check. And then it has to move back and seal on the back face. And this process we felt took place in the early part of the ignition transient, someplace before it got to 200 psi. And in cold weather, what's going to affect that is, of course, the grease that's in that area also is very viscous and stiff. The O-ring itself is stiff. We knew that the cold temperature shrank the O-ring some. And from our resiliency tests, which are tests that basically show how the O-ring responds when you have it under some compression and release that load, shows that as it gets cold and stiff, it doesn't want to respond very well. And I looked at it something like a flat tire on the bottom of I remember when I used to drive nylon tires when it was cold, I'd get out and there was a flat spot on them. And that O-ring having to move, it either's got to slide or it's got to roll somewhat. It's not a very big dimension it moves in. It's 20, 30 thousandths. But certainly can't be as good as when you don't have that. Also being hard, it then has to extrude into the gap between the two O-ring seals. And the harder it is, I'm sure it's harder to extrude in that gap, which means it may take a higher pressure to do that, which also takes longer time. I felt that based on what we had done in the past, we had concluded that this blow-by phenomena had really occurred in this first part of the pressurization cycle. And I think there was good evidence that it had, because the soot that appeared between the two O-rings was exactly that. It was soot. We analyzed it, but it didn't see any heat effect on the metal at all. In some cases it discolored the grease, but didn't really burn it. Some of it was a product of the grease. We could not see any real effect on the secondary O-ring, so it couldn't have happened very long, and it couldn't have happened under very severe conditions. But at the same time, the temperature effects were concerning, that maybe we're going into another timing regime. However, if we felt that we had a good margin there, then we felt that we do have a good secondary seal during this time. And I think there's been some misconception about the redundancy of the secondary seal. The secondary seal is indeed redundant until the metal parts between the tang and the clevis actually rotate. It's a full redundant seal, and during this time period it is redundant, and that's important. But once those metal parts rotate and you have a problem with resiliency, it may not be. So that's why I was concerned about that area, but if we could convince ourselves that the data said it wouldn't make that much different in that part of the phase, then it would be a reasonable recommendation to say that we wouldn't expect much different performance. But shortly thereafter, that Thiokol was asked about their recommendation, I believe, and Joe Kilminster was asked himself what his recommendation would be, since it was engineering that had recommended not flying at 53, and he said that he would not go against that recommendation. He couldn't go against it. But based on the controversy relative to how conclusive the effects of temperature actually were on this phenomena, we were asked to reassess and reevaluate that data. And we decided we would do that, and the people at Utah said that, well, they would like to have a caucus for about 5 minutes and go offline.
I ask you to stop there just for a moment and go back. We'll come to the caucus in a minute, but come back and explain what was said to convey the decision of no launch. I gather at that point the decision by Thiokol was to recommend against a launch. Is that correct?
That's correct. It was at that point the recommendation was not to launch below 53 degrees.
Who did this talking on that subject? Was it?
That was Bob Lund, the Vice President of Engineering, presented that position. But
were you able to ascertain from that conversation how the engineers as a group stood on that?
Well, the engineers as a group, I can't speak for the group. I was not there, but I did hear the engineers that presented the charts that they actually presented as part of that supported the 53-degree recommendation. And I felt they're very strong in their conviction as why they felt uncomfortable to go outside that experience space.
And who were they?
Roger Beaujolais, I think, was one of the strongest ones, and Arnie Thompson that presented those positions and presented the charts.
And Mr. Lund himself at the time?
Yes, Mr. Lund himself at the time didn't present the detailed technical charts, but he did present the conclusions, recommendations, and that was his recommendation as Vice President of Engineering.
Was anybody on who was on the telecom from Thiokol's side recommending launch?
At that time, no. There was no one that recommended launch, and I don't recall there was anyone at either Marshall or Thiokol from NASA that didn't agree that cold temperatures went in the wrong direction, didn't help anything, but no one from Thiokol at that time recommended launch.
And what were the comments by NASA officials about that recommendation that you recall?
Well, as I recalled, there were some fairly strong comments about being appalled by the recommendation, about trying to institute new launch commit criteria at the last minute, about when we'll ever get this launch off. I thought those were fairly strong comments.
And those were comments, according to your recollection, were made by whom?
Well, the comments relative to the launch commit criteria and when we'll ever get this off was made by Mr. Larry Malloy. The comment about being appalled was George Hardy. He was at Marshall. I think I recognized his voice, but that was by voice recognition.
So it was decided at that. Any questions, member of the commission have at that point in the narrative?
Mr. McDonald, I have one question. Before you went off the net, did you ask or make a comment about the secondary O-ring seal seating? That has been.
Was I asked to make one?
No, did you make a comment?
I did make a comment, yes, I did.
Could you recall that comment, please?
Yes, I think I read it to you, and I'd be glad to do that again. I made the comment that lower temperatures are in the direction of badness for both O-rings because it slows down the timing function. But the effect is much worse for the primary O-ring compared to the secondary O-ring because the leak check forces the primary O-ring into the wrong side of the groove, while the secondary O-ring goes in the right direction. And this condition should be evaluated in making the final decision for recommending the lowest acceptable temperature for launch. That was a comment I made.
Did that confuse some people? Some of the witnesses I spoke to thought that was a comment in support of the launch, the fact that this secondary O-ring seal would seat.
Well, that comment is a good news, bad news comment. There is good news and there's bad news. The good news is that the secondary seal is in the right position, but that's not unique to temperature. It's always that way. The bad news is that the primary seal is the one we're depending on for the full ignition transient, and it's going to be a lot worse than it was. But even the secondary, as I mentioned, wouldn't be as good cold as it would be normally.
But by this comment, you were not supporting the launch.
No, not by that comment. I wasn't supporting the launch. I was just saying that's an important consideration, and I felt that if we could run some calculations to show that the temperature did not affect the timing, then that would be supportive of a launch. If it did, it certainly, and that was the concern, that if it pushed that timing out long enough, we had a chart in there that said that if that timing goes beyond that 200 psi regime while you're still eroding the primary O-ring, that for whatever reason, if you ever bypass it at that time, you can't depend on the secondary, and that's what's important.
At the time of the caucus, then, you never favored launch.
No.
And you made it clear that you were opposed to launch.
Well, I never said I was opposed to the launch. I just made a few comments about why I thought some of the data was not appropriate, like the static tests were saying the O-rings were good to 36 degrees. I made this comment about the lower temperatures affecting both O-rings, but it affects them a little bit differently because one of them, it's a dynamic O-ring. It moves. One of them has a lot more movement and effects on it than the other one does because it has to move across the groove. I made those comments. But
you accepted the recommendation?
I accepted the recommendation, yes. I thought it was an appropriate recommendation.
In other words, you accepted the recommendation of no launch that was made by your company?
That's correct.
Mr. Armstrong?
Would you be surprised if your comments were interpreted by both your own company personnel and Marshall personnel as being supporting of the Marshall position?
Yeah, I would be surprised at that, yes. I think I wouldn't be surprised that that would be evaluated as the effect of that, but I'm surprised that was interpreted as supportive, yeah.
Okay.
Mr. McDonald, you mentioned a 40 to 90 degree qualification limit. Was that referring to ambient air temperatures?
Well, I had a discussion about that later. It was my impression that the motor itself was qualified from 40 to 90 degrees for operating. And we got into a discussion, in fact, during the caucus that was supposed to last for 5 minutes, that lasted for about a half hour on that very subject. I told the people that were there from NASA that I, first of all, didn't agree that the motor was even qualified from 40 to 90 relative to all of its elements and subsystems. I wasn't there in the qualification of the steel case motor, but I just recently went through that process in the film wound case SRM, and that I'm not aware of the testing or analysis of the O-rings were good to those temperatures, and that therefore it's part of the elements, and the way I interpreted the spec is that all of the components and elements that make up the SRM should be qualified to those temperatures. Mr. Larry Malloy at that time told me, well, no, the 40 degrees refers to a propellant mean bulk temperature. And the propellant mean bulk temperature was being predicted to be 55 degrees for that launch. And that as long as the propellant mean bulk temperature wasn't below 40 degrees, that you could expose the other parts of the motor to lower temperatures as long as you didn't drop the propellant mean bulk temperature outside of the 40 degrees. I responded, I told him I thought that was absolutely ridiculous because you could expose that motor to very severe cold temperatures, sub-zero temperatures for a fairly long period of time, and you wouldn't change propellant mean bulk temperature at all. There's such a massive amount of propellant insulator there that it takes a long time to do that, and I'm sure that the spec really didn't mean that you could do that. And so my interpretation was certainly different than his.
Was there, in fact, a minimum temperature established by specification or by rotor in some manner that related to the O-rings or the joint?
Well, I wasn't aware of one for the O-rings. I found out later that there was in our specification, it refers to a higher level specification, which is level 2 at Johnson. I think it's 07700 spec that says that the shuttle vehicle has to be capable of launching in 31 to 99 degrees or something like that, and therefore, since it's a higher level spec, that we should be able to comply with that. But I'm not aware that all of the elements and subsystems were ever qualified to that.
What do you mean by higher level spec? Could you explain that?
It's that specification come down from the Johnson Space Center, who is responsible for the overall operation of the vehicle, shuttle vehicle. and what it's capable of operating in the environments, both pre-flight and flight. And that specification for the overall vehicle gets incorporated as part of the lower level specifications that go through level 3, which is Marshall Space Flight Center, to the various elements, and they refer to that. And when they refer to that, the way the system's supposed to work is you're supposed to comply with your own specification plus any higher level specifications that may involve the entire shuttle system. And I was unaware of that, frankly. That criteria was in there. I'm still a little bit puzzled about it because it doesn't have any time limitation on it either. I don't know if it's 31 degrees for 5 minutes or 40 days.
Was there a FIACO design temperature limit at the time this motor was designed with respect to low temperatures?
I really can't answer that because I wasn't involved in the original design qualification.
If I may, I'd like to continue. We can come to some of these other questions. I'd like to continue the chronology because we were going fine, and you stopped about the caucus. Mr. Armstrong has a question, and
one question supporting your answer that you just gave. Had Morton Thiokol, to your knowledge, ever informed NASA that the launch commit criteria were inadequate or did not in fact cover the kinds of conditions that you were concerned about?
I'm not aware they ever did, not to my knowledge.
And so we're really talking about an event that was within the launch criteria, launch commit criteria, but outside what your experience base was.
Well, I guess I'm not convinced of that either. I didn't learn about the 31 degree thing until sometime afterwards, but we were told to make this evaluation on the basis of launching at 09:38 in the morning where the predicted temperature was 26 degrees Fahrenheit. That was predicted temperature, and that was the decision that was made whether we could launch at that time. So I'm not sure where that came from either.
Dr. Ryan?
Yeah, just one follow-up to Neil's question. Are you aware of NASA ever asking Thiokol to qualify the SRM or the SRB to 31 degrees?
I'm not aware of it, but again, I wasn't in that part of the program. They may have. I can't say when that was.
If we may now, let's go back. You said that a suggestion was made that have a recess for 5 minutes. Who made that suggestion?
That suggestion was made from someone at Thiokol. I can't recall whether that was Joe. I think it was probably Joe Kilminster, but I'm not sure.
Okay, now what happened? You said that lasted almost a half an hour instead of 5 minutes?
That's correct.
And during that time, what did you do and who were you with?
Well, I was in the conference room at Kennedy with Mr. Reinhardt and Mr. Malloy, Mr. Houston, and Jack Buchanan still, and I gave you my conversation about interpretation of the qualification temperature there. I also commented at that time that I suggested that maybe we consider a late afternoon launch. I didn't feel good about the low temperature launch because when I had first come down to Kennedy, the original schedule was to launch that in the late afternoon, I think 3:45 or something like that, and based on the weather report I heard, the temperatures would be 48 to 50 degrees in the late afternoon. So I said, why don't we go to a late afternoon launch? And I was told that that was considered, but it was rejected because of some problem either with visibility or weather at one of the transatlantic abort sites. I think it was Dakar or Casablanca, one of those. I really expected the reason it was taking so long for this 5-minute caucus was that we were either trying to find some more information to support our recommendation or that we were trying to run some kind of calculation to determine how far away from that we could go, because clearly 26 degrees was a long ways from 53. I personally felt we certainly wouldn't go below 40 because I thought my interpretation of the qualification was correct, and we wouldn't do that. But that reason it was taking long is the engineers were reassessing all the data they had and finding any more that they may have and trying to quantify more of it. A lot of that data was very qualitative. And finally, the people from Thiokol in Utah did come back on the line after about a half hour, and I believe it was Joe Kilminster came on the line and said that even though we had some concerns about the lower temperatures, that we would recommend that they proceed with the launch based on the fact that we felt the temperature data that we had was not totally conclusive. And he outlined several concerns still that we had relative to the effective temperature, but also some rationales why we felt it was safe to proceed.
Did you relate what he said?
Well, it was the information basically that ended up finally on the facts statement relative to our concerns, the O-rings being colder and harder, and but that we also had some data that was inconclusive relative to temperature, and I'm sure it was the warmer temperature launch where we had some blow-by. I didn't see anything that I recognized that was new information, but maybe they had some, and I felt all the engineers were certainly there that had generated the original data and evaluating it, and maybe they had reconsidered or reevaluated the data they had and tried to quantify it, or felt it was probably okay. When he completed that, he was asked, I believe it was by Mr. Hardy, I'm not sure, to put that rationale in writing and to sign it. Make sure they get it down to the Cape, I think, by morning, early morning. And I was sitting across the table from Larry Malloy at the time, and I said, well, I felt that I was one that was going to have to sign it because I was at the Cape. And I said I wouldn't sign that. I couldn't. It'd have to come from the plant. Joe Kilminster said that he would draft a letter or a statement and send it down, and he would do it tonight. Wouldn't wait until morning, and I was instructed to stay there until that came down, and that he would also send it out to Marshall, and then it'd be a few minutes before that would come down. He went off line at that time, and I asked Cecil Houston where the fax was, and he told me it was at the other end of the building. I had a conversation with people at Thiokol just before they went off the line where they can send that information into Jack Buchanan's office, which is a fax machine right next door to this conference we had, or they can send it into the Marshall office. They had a Pitney Bowes machine or something, and they said, well, we'll send in the same one we sent all this other material because they have the right number and all, and that happened to be the Marshall one, which was the other end of the building. So I said, fine, I would wait. Again, it took some time for that fax to get there, so all of the parties were in a meeting, were still sitting there, and we started to talk about some things. I told them I didn't feel very good about this recommendation, and that I recognize it's very difficult to quite quantify at which temperature these seals may be acceptable and where they aren't acceptable. Based on that data, some of it certainly was inconclusive. There's no doubt in my mind. And that's a difficult thing to quantify, but even though I didn't agree with the 40-degree qualification of the motor, that all elements were qualified to that, it's my understanding that there was a lot of people at both NASA and Thiokol signed up to that. So the design certification process, through the critical design reviews, and I was absolutely surprised that NASA would accept any recommendation below 40 degrees Fahrenheit, especially when the predicted temperature is as low as 26 degrees Fahrenheit. I told them I may be naive about what generates launch commit criteria, but I was under the impression that that was generated based on the qualification of all elements or subsystems of the Space Shuttle, that anything that was outside that qualification was a launch commit criteria, and we never went outside that envelope. And I don't know why NASA would ever launch below 40 degrees Fahrenheit if that's what the SRM was qualified to. In fact, I made the direct statement that if anything happened to this launch, told them I sure wouldn't want to be the person that had to stand in front of a board of inquiry to explain why I launched this outside of the qualification of the solid rocket motor or any shuttle system. When I made that statement, no one commented on that. I was still very upset, so I asked that they reconsider this decision for three reasons, not one, for three. And I said if I were the launch director, I'd cancel this launch for 3 reasons, not just one. First one being the concern of the cold O-rings that we just discussed. But there were 2 others. I just left Carver Kennedy's house in Titusville, Florida. And he's responsible not only for stacking of the SRMs, he's responsible for the retrieval operations. And he had been in communication with someone that was at Hangar AF, I believe, that contacts the booster recovery ships at sea. And they had told him that the booster recovery ships were in an absolute survival mode, was how they put it. That they were in seas that were high as 30 feet. There was winds at 50 knots sustained, gusting to 70 knots, pitching the boat as much as 30 degrees. They even felt the rough seas may have damaged some of the retrieval equipment on the back of the ship. They were steering directly into the wind, heading for shore at about 3 knots, and they've been doing that for some time. There's no way that they would be able to support an early morning launch because they wouldn't be in the recovery area. I then reminded everyone in the room that, there's some firsts on this launch. This is the first time that we're going to use a new electronic control system for separating the nozzle extension cone on the SRBs at apogee rather than just before water impact while it's under full main parachute. And then we were going to separate the parachutes at water impact for the very first time on this launch. And that, based on the sea states that I had just heard, that appeared to me that it was going to be nearly impossible to recover that hardware, either the parachutes or the frustrums. And also I felt that they were putting the boosters at some risk as far as recovery was concerned because the ships were steering away. I also said that the third reason for not launching is the formation of ice. I knew the sound suppression system's a water system, and I felt there'd probably be a lot of ice around there, and I'm no expert on all these matters, but I do feel that there may be a chance of that changing the acoustics, may be a problem with debris, may have some effect on the structures. I didn't know, but I didn't think it was prudent to launch under that kind of a condition. I was told that, these weren't really my problems, and I really shouldn't concern myself with these. But I said, all 3 of these together should be more than sufficient to cancel the launch, if the one that we had discussed earlier wasn't. The NASA people were there said that, they would pass these on. They could tell I was disturbed, and they would pass those on as concerns, and that they would do it in an advisory capacity. I was then asked by Mr. Malloy where the signed fax was, because some time had transpired since the teleconference had ended, and it still wasn't there, so I said, okay, I'll go check on that. And I went down to the other end of the building to this fax machine, and there was nothing there and come out yet, and I really wondered if it was working. It was getting kind of late. So I stayed down there, I guess, for about 10 minutes, and it finally came in. I brought the fax back. It was a single sheet of paper. To Jack Buchanan's office where we reproduced copies for everyone. I walked into, I think it was Cecil Houston's office there, and there was a telecon being conducted, and I believe it was with Arnie Aldrich. And they were in the middle of this telecon, and they were discussing the conditions of the booster recovery ships and the high sea states and the fact that they were in a survival mode. And I recall that Arnie Aldrich asked Larry Malloy if he felt there was any risk to recovering the boosters because of this, and he said no, he didn't think there was any significant risk in recovering the boosters because they had beacons and monitors and they were going to have aircraft in the area also, but that there was a high probability that they would not recover the parachutes or the frustrums. And the conclusion was that I guess they'd have to make a decision to launch on the basis that they would have a high probability of not recovering that hardware, but they weren't compromising the recovery of the boosters significantly. And I remember Arnie asking Larry, the value of that hardware, and I think he gave some number close to $1 million and asked him if he could afford to lose it and support the schedules of the program. And he said that he had sufficient inventory to do that. But Arnie also told him that in no way have those ships attempt to turn around in those kinds of conditions, and the safety of the ships is important to try to support that launch and turn around too soon. So to tell him to continue on toward shore until it was really safe to turn around. They then briefly discussed the ice issue, about the ice, and there was a concern raised there, and Arnie, I believe it was Arnie, responded that they had discussed that issue earlier in the day. So it was a fairly brief conversation. And heard the ice, so I don't know. And finally the conversation concluded, and the recommendation was to proceed on with the launch. I stayed around a few more minutes and talked to Jack Buchanan for a few minutes, and went back to Carver's house in Titusville, where I stayed, and got in there, I guess, a little before 1 o'clock sometime. And, I guess that's all I have to say.
Dr. Keel asked at the conclusion of your testimony in executive session whether you felt that you were under pressure or had been under pressure, or the company had been under pressure to reverse its decision. And I think your answer was yes. Do you remember that?
Yes, definitely. There's no doubt in my mind. I felt some pressure. I feel that I have a responsible management position in here, and I felt pressure by the strong statements from me.
Would you explain the reasons for feeling pressure?
Well, I've been in many flight readiness reviews, probably as many as anyone the past year and a half at Thiokol. And I've had to get up and stand before, I think, a very critical audience at Marshall, a very good one, justifying why our hardware was ready to fly. And I have to get up and explain every major defect and why we can fly with that defect. And to the most part, they're very minor, very, very minor. And I've been hassled about how I'm sure that that's okay to fly with. You know, such things as losing vacuum in a carbon cloth phenolic part in the nozzle while the part's basically cured. You know, it doesn't really affect it, but it's a critical process. There's a lot of those critical processes. And I have to address every one of those to great detail as why I'm sure that that part has not been compromised. And it's been that way through all the reviews I've ever had. And that's the way it should be. It's not pleasant, but that's the way it should be. And I was surprised here at this particular meeting, the tone of the meeting was just opposite of that. I didn't have to prove I was ready to fly. In fact, I think Bob Crippen made the most accurate statement I ever heard. His conclusion in that meeting was that philosophy seemed to have changed because, you know, he had the same impression I did, that the contractor always had to get up and stand up and prove that his hardware was ready to fly. In this case, we had to prove it wasn't, and that's a big difference. And I felt that was pressure.
And can you explain a little more what source the pressure came from in your mind?
Well, I think the strong statements that were made by Mr. Malloy and even some of those that the people at Marshall that were on there, Mr. Hardy, were, I think, fairly strong statements that I took as pressure about when we'll ever fly this thing and launch commit criteria that we can't generate at the last minute, and appalled by our recommendation to fly at temperatures high as 53 degrees, and that, to me, that was pressure to me, and it may not have been interpreted by others, but it was pressure to me.
Any other pressure that you want to refer to at this time or at any time?
No, I just felt that the way the comments were made, as strong as they were made, and the fact that the conditions for justifying this launch were so much different than anything I had been involved with before.
As far as the telefax is concerned, would you normally have signed that telefax, or was the procedure that was followed the normal procedure?
Well, I'm not sure, I guess, what the normal procedure is. I felt that since I was there representing, I was a senior official at the Cape, then I'm the one that usually is responsible for that. I know at the L-1, when we have a normal launch, there's a poll that's conducted by Jess Moore of all the contractors where they're ready to fly, and I'm the guy there that has to get up and say, yeah, Thiokol's hardware is ready to fly. I felt that's my responsibility. That's why I'm there. I can't recall where we were asked to sign anything like that before. We have a presentation that's given at every flight readiness review that's signed off by the principal parties. Joe Kilminster usually signs all those on the formal review, but if anything comes up afterwards, it's been done on an oral basis. But I don't know. I've never been put in that position. I don't know if Joe has. I don't believe he has.
So the fact that a written decision was requested, as far as you were concerned, was not the normal way to do it.
It was not the normal as far as I was concerned.
And as I recall your testimony, you testified that you made it clear that you would not sign a written statement approving the launch. Am I correct?
Yeah, that's correct, and I think that's been misinterpreted, at least by the press. They said that I was overruled by my supervisor. That's not true at all. I chose not to sign that. He didn't overrule me. I felt that decision I started was an engineering decision by the people that understood the problem the best, that had all of the data and facts, and they're the ones that should recommend it, and that's why I made that. It wasn't I was overruled.
Thank you very much. I'm sure other commission members will ask some questions. Mr. Armstrong?
You were talking about the 40-degree qualification of various components of the solid rocket booster. And I was aware of the 40-degree limit on the grain bulk temperature, but was there anything else that the 40 degrees referred to?
Well, in the spec, going back after the fact and looking at it, that's what it refers to as the propellant mean bulk temperature. I guess that's, in my opinion, is an oversight maybe in the spec, or the launch temperature of 31 to 99 should be stronger in there to apply to all components. And by qualification, it either has to be qualified by test or some analysis, and that means every element. And I'm not aware that all those elements were qualified to that temperature. I know we bought O-rings that said they're good to minus 30, but I never saw the analysis in the application that we use them in that says that they're good to that. And that's a difference. It's a material problem versus a design problem.
I understand that, and I understand that the 40 degrees was intended to protect against grain cracking and the consequences of that, but what I didn't quite understand is why you said you wouldn't recommend any time launching below 40 degrees. I'm trying to get a...
Well, the reason I said that is I felt that's what everybody had signed up to, is what this thing was really qualified from an operating standpoint. Now, the motor does get exposed to much lower temperatures. We have a criteria in our specification expose that to much lower temperatures, sub-zero temperatures and 60-mile winds coming across Wyoming, because we ship these things from Utah down to the Cape. So in a transportation mode, they are subjected to some very severe temperatures for periods of time. And there has been analysis to show that they will withstand those temperatures as long as you don't operate them at those temperatures. The 40 degrees, they won't crack. There's no problem there. That's primarily a performance standpoint. You lose total impulse and performance the lower the temperature you go. If you get below 40, you start losing performance out of the shuttle, and that's why that number came about. As far as the capability, the grain structural capability, it can withstand a lot colder temperatures than that. And we have analysis for the storage and transportation that shows that, and it has good margins of safety, very high margins of safety for exposure to lower temperatures. It's just that things like the O-rings and some of these other components, I'm not aware that we have really analyzed or tested those well enough to understand how they would operate in that kind of a temperature. There's a difference between exposing them and storing them versus operating them.
Thank you.
I have a question, just referring back to the static test which you mentioned, 36 degrees, which was used as a justification. Was there an analysis to indicate what the O-ring temperature during that test was?
Well, it was done after the fact, and I believe in the presentation that was made on the night before the launch, they calculated like 47 degrees is what they presented as what they expected the O-ring temperature to have really been when that was static tested.
I have a couple of other questions regarding the conference. Was there a specific request by NASA to reconsider, or was the reconsideration as a result of the implications of the remarks made by the NASA people in the conference?
I mean, the reconsideration of what?
Of the initial decision not to launch. That is, the initial recommendation of THIACOL was not to launch, and then that was reconsidered. Did anyone from NASA explicitly ask for reconsideration, or did the reconsideration occur because of the negative remarks and comments on that decision?
Well, I think it was the latter. I can't fully recall whether they directed us to do that or not, that they had concluded that the temperature data was inconclusive, and I don't know whether we volunteered to reassess it or they said we need to. It's not clear to me on that. I'm not sure.
One further question in regard to the signature on the sheet which was faxed from Mr. Kilminster. Was there a specific request for that to be signed, and who made that request?
Yeah, there was a specific request for that to be signed. I believe it was George Hardy. It may have been Larry Malloy, but I think it was George Hardy had requested that.
Mr. McDonald, did you consider bringing your concerns about the final recommendation to the personal attention of Mr. Moore or Mr. Ulrich or Dr. Lucas?
Well, I'm very familiar with the process by which these things are reviewed, and I was absolutely positive and sure that they were brought to their attention, because that's the way things go. I talked to the SRB project manager, I talked to his boss, the shuttle project manager, the shuttle project office, and I was sure that those all went through that review. I had no doubt in my mind that they had.
Thank you.
You indicated that NASA folk indicated that they would pass your concerns along, and I presume that you thought they would. The three concerns that you were talking about, the O-rings, the ocean, sea, and the ice.
Right.
But could they have simply meant the last two concerns, the sea and the ice? That's one question. The other is, who were the NASA folk that promised to pass your concerns along?
I guess you could interpret maybe as I thought it would be all three, but the people were Mr. Malloy and Mr. Reinhardt said they would pass those on, and I presume they'd pass them all on. I didn't see any reason why they wouldn't.
Mr. McDonald, you mentioned earlier that you thought this decision on launching should be an engineering decision, not a program management decision. How would you characterize the final decision to launch from THIACOL? Was it engineering or was it management?
Well, I guess I'd have to characterize it as a management decision, the final decision.
Thank you.
I've got a couple of questions on Criticality 1s. Did I understand you to say that you chair the board on Crit 1s on the SRM from THIACOL?
Yes, on all defects that are affected by that, yes.
Could you give us your understanding of the meaning of Criticality 1 and just an estimate of how many parts in the SRM system are classified as Crit 1?
Well, I don't have a good number for you, but there's a tremendous amount of Crit 1s on the SRM, primarily because the motor doesn't have very many redundant features. Solid rocket motors don't. And, of course, a lot of it's structure, and structure is all becomes a Crit 1 if it fails.
Could you define a Crit 1?
Crit 1 is a single-point failure that if that element fails, there's no recovery. You lose the hardware, and it's catastrophic. There's a lot of elements in the SRM that are under that category. Relative to the O-ring seals, the redundancy was built in because that was a critical element as a pressure seal in order to provide that redundancy. I think there is some confusion of late as to what that Crit 1 and 1R was relative to seals and how it was removed. I wasn't involved at the time, but it was found that because this joint rotated, that if you took all of the worst engineering tolerances and dimensions that were allowed by the prints, and that means the maximum clevis opening you could have to start with, the smallest and thinnest tang that you could put into that clevis opening, and the minimum O-ring that you could put in there, with the maximum size of the grooves that you could possibly put in there, that you put all those combinations together, you could show that you would actually lose squeeze on the secondary O-ring once you pressurize the system and the joint rotated. And therefore, if you ever had to call upon that O-ring as a redundant system during that time period, you couldn't depend on it. Now, I went back and had an assessment made of have we flown any hardware in that condition, because I was a bit shocked about that as much as anyone when I first found that out, which was, by the way, last August, when I made that presentation here to NASA headquarters. I was unaware of it myself, that we had such a condition, that we were flying with a Crit 1 on that part of the hardware. Based on the information that I have received on all of the joints ever flown on the shuttle, there was only one time where we had a tolerance stack-up of a joint that would have fallen from a criticality 1R to 1, and that was on STS-4. We have never had one since. We didn't have one before that. We always had adequate squeeze from the hardware when it rotates to maintain it as a criticality 1R. Now,
I'm not quite sure I understand that, because I thought that the piece of paper in the critical items list specifically lists the primary O-ring as a criticality 1.
Yes, it does, and the reason it does that is because the drawing tolerances allow you to install hardware that may come together on a worst-case basis that cannot guarantee a secondary seal, and therefore if you can use all the hardware that's in the inventory, or you could possibly have in the inventory, build to acceptable prints, you could end up with a very small fraction of it. It's a very small fraction that could go together that way, and therefore that document was written to cover all that. But in reality, other than that one case, we've never assembled hardware that way. We haven't had the thinnest tangs with the widest open clevises with the minimum O-rings ever put together. That's a concern, and a seal is a very serious concern in my opinion, because that decision was made at the time based on what we knew about joint rotation. Since that time, we're getting this information on resiliency and effects of temperature, which were never put into that at that time, that brings that question back out in front. I told you we didn't fly from criticality 1R and 1. Well, that's true based on the decisions and the information that's known that changed it from a 1R to 1, just on the tolerances and dimensions. As far as this resiliency thing, I can't assess that yet well enough to know. But I do know we never stacked hardware together that had tolerances so bad that we didn't have contact of the secondary O-ring other than one joint.
But just to be clear, I guess that you don't, on a joint-by-joint basis, go back to the NASA board and kind of reclamor the Crit 1 and turn it back into a 1R, do you? It's always classified as a criticality 1 on the primary seal.
That's absolutely right. You're correct. Now, we do, as part of our flight readiness review, present those joints that we're mating and what those O-ring squeezes are on every flight.
Did any discussion of the primary seal as a criticality 1 come up during your meetings on L-1?
No, they didn't.
Okay, thank you.
You suggested that the secondary seal would not be much affected by the temperature, but now you're telling us that because of the complete or nearly complete loss of resilience, that is the tendency to spring back, the secondary seal would require very little rotation to open. Do I understand it correctly?
I said it wouldn't be affected as much as the primary seal because it doesn't have to move from one end of the slot to the other, but as far as the effective resilience, you're absolutely correct. It still has the same problem. As far as extruding in the gap, it's still got the same problem.
We were talking about, somewhere there was a discussion about the secondary seal being redundant until the metal parts rotate. When the pressure starts to build up, it can't move the primary seal until there is some pressure. And then there's a very small pressure, perhaps, and a very small rotation. Isn't it true that the rotation is more or less proportional to the pressure, or is there some delay of some sort?
There is some delay.
Why is there a time delay between the two?
There is some delay because the joint's stiff enough that under certain pressures you just don't move it at all until you have to build up some pressure to make any rotation. So there is a delay in that time period, but at some point in time it becomes a direct function of the pressure.
Isn't the laws of elasticity such that everything is proportional to the force and all of the displacements are proportional to the force? Then wouldn't it be true that at every pressure there's some rotation and the rotation is more or less proportional to the pressure?
Well, I think that when you're down to a few psi or 50 psi, I don't think you're rotating anything.
You're rotating at 1/10 as much as you rotated at 500 psi, is that right?
Well, the structure is so stiff that I can't believe you're rotating at all at 50 psi. You are moving the O-ring seal back into the groove, however.
Just to go back to this criticality 1 so that I can understand it a little better. In 1985, change was made? 83? 83, I guess it was 82, 83.
I think it was.
At that point, it was listed as criticality 1 with an R. Is that right?
That's correct.
Now, does that mean that it was decided that if there was a failure in that seam O-ring, that the mission and the crew would be destroyed, the whole thing would be a catastrophe? But at that point, the R meant that there was a redundancy there, that you had 2 rings, and each at that point was considered to support the other, or at least one was a backup for the other. That's what R meant.
That's correct. It's redundant. It means redundant. That's why the R is there.
That's right. Now, at that time, experience fairly demonstrated that the analysis that you'd been using up to that point may not have been correct, so that instead of having both a primary and a secondary seal which provided redundancy, you came to the conclusion you didn't have the redundancy. Therefore, it was changed to criticality 1. The R was removed. Is that correct?
That's correct.
And so from that point on, I believe it was in, what's the date?
December 82.
December 82. Those shuttles have been flown on the basis of criticality 1. So there was a failure of that seal, a catastrophe would result because there was no redundancy. Is that correct?
Well, I guess that's the interpretation of that, but recognizing the actual hardware that was put together and what we knew at that time, I don't believe that was true. What was true was that the drawings, as I mentioned, allowed a condition where you could fly that hardware in that condition.
But just to be clear, what the SIL says is that the primary O-ring is a criticality 1, and you're not allowed to consider the secondary O-ring as a backup to that.
That's true, Sally. That's absolutely correct. That's what it meant.
And that was known, I assume, by everyone that was working on the program, or most of the top people working on the program. Would that be true?
Well, I kind of thought I was one of the top people working the program, and I didn't know that until August of 1985 when I put that presentation together. I presume it was. I did find out there was some disagreement between both Thiokol and Marshall in interpreting that relative to the joint rotation. The joint rotation that was used for concluding that was obtained from 2 different sources. One of those sources was from the Structural Test Article 1, the first structural test article, and this was way before my time, but where this test article was taken to Marshall, and it's basically a forward segment. It's unloaded now, and an aft segment, and where they input both the pre-launch loads, and they put flight loads and all that business into the test article. And this test is run horizontally. The arm's horizontal, and they measured through the leak check port, I understand, or some places, the actual rotation of these parts. And got some fairly high numbers, up around 60 thousandths, I believe, is what they said it rotated. We had run some tests ourselves in a vertical assembly during our hydro test. and measured some of the rotations and got numbers like 30 to 40 thousandths. So there was some disagreement as to which numbers were correct. Some of our people felt that the horizontal assembly may have made the structural test article numbers not representative. The vertical assembly is better. And in fact, because of that disagreement, we're in the process and started early last summer at the direction of Marshall to come up with what's called a referee test, to do some very careful instrumentation in a vertical assembly to get a better handle on the exact amount of joint rotation. Those joint rotations that are used are those that are predicted for the maximum expected operating pressure, which, by the way, we've never obtained. Fortunately, I hope we never do, but that's a 3 sigma out there someplace. But that still is a point of controversy as to what that number really is, because the SIL, I believe, the critical items list that changed that from 1 redundancy to 1, not only assumed the MEOP, but I believe it assumed the larger rotation, which is about 50% more than some of the data that we got from vertical. So I still don't fully understand that. What I do understand is that it was made at a time when temperature effects were not known. And the resiliency problem that Dr. Feynman brought up, I think, is the more serious one.
May I ask? Oh, excuse me.
I just want to finish this. Okay.
Sure.
Going back, though, beginning in 1985, when you realized that the criticality 1 was on the critical items list, you knew from that point on that a single failure would be catastrophe as far as the mission is concerned.
Well, as I mentioned earlier, that you have to postulate what your failure mechanism is, and I felt very strongly that the blow-by that we had observed indeed was on the early part of the ignition transient. I think we all felt that way. We've modeled that, by the way, I think fairly reasonably on the erosion. And that at that point in time, when the hardware really hasn't had a chance to rotate, taking the temperature effects out now, that we do indeed have a good redundant seal, because if we lose the primary O-ring at that time, that secondary seal is in a better shape than the primary to really seal. It hasn't come off its land at all if you ignore the resiliency problem.
Can I ask your opinion in a different scenario? Suppose that as the pressure is increasing, for some reason, the primary seal, just to understand what the situation is, the primary seal begins to erode, and by the time the pressure gets to some figure like 600 or 700 psi, which is, I think, just below the maximum operating pressure, it finally erodes all the way through so that the gas can pass through the primary seal. Would you think there was a reasonable probability that the whole thing would fail because the rotation by that time is enough that the secondary seal can't hold it?
Yes, I think there was. And that was our assessment in August, that there was a reasonable probability.
Okay, that you first knew or thought of in August 1985.
That's correct.
Not before.
That's correct.
Thank
now, following up on that, wouldn't you assume that other people who had been working on the program and working on the seal and the O-rings would understand that too?
Yes, I think there's another important piece of information. Back in the end of April, 85, forgot the exact flight, but it was the last one in April. We had a problem with the O-ring seal in the nozzle. That flight, after it came back, the nozzle was still attached to the aft segment, and we disassembled the segments when they were brought back to the port. And then they're put on rail cars and sent back to Utah. We never got the segment back until, I don't know, sometime in the latter part of June or something. This flight was at the very end of April. We disassembled that nozzle. We found that we had violated the primary seal, back in 3 locations, and burned completely through it. The secondary seal also had eroded like 32 thousandths. But it held and it did its job. That was in a nozzle joint. The primary seal in the nozzle joint is a bore seal, quite similar to the field joint. Tolerances are a little different. But the secondary seal is a face seal. It's they're both somewhat dynamic seals, but it's more of a static seal than the bar seals. The face seal is torqued down with the bolts, and it obviously did its job. And our conclusion was, in that particular instance, was that even though we passed the leak check, that the vacuum putty may have masked that leak check. We were using at that time a pressure, stabilizing pressure to run that leak check at 100 psi. We had some data earlier that showed us that the consistency of that putty is quite variable, and you can actually, the putty will become a good sealant in many cases, and it can hold as much as 100 psi for a good period of time. Sometimes it'll blow through, sometimes it won't. So our concern was that maybe we're not really checking the O-ring seals, we're checking the putty, and we've got to make sure we're checking the O-ring seals. So we jacked the pressure up to 200 psi. That was the last flight that we were still under the 100 psi, which was the previous requirement. To stabilize it at 100, and then once you stabilize it for a period of time there, you drop the pressure completely again, you bring it up to 50 psi, and that's what you run the leak check at for about 10 minutes. You only allow 1 psi drop. On that particular set of hardware, since it was the last one we ran with 100 psi, because the change hadn't gotten through with all the paperwork system on what we understood about what putty behaves under pressure, because we'd went to 200 psi for the field joints at that time, just hadn't gotten the nozzle. We concluded that the putty may well have masked that leak check because it was at 100, and therefore we may have had some defect in that seal that we didn't detect. And as a result, that seal leaked at ignition from time 0. And when that happens, you get severe erosion on the O-ring because you get the jet impingement that we've been calculating, which is direct onto the O-ring seal, like a flat plate. But when you bypass the O-ring in a leak like that, it actually chokes at that point, so you're forming a throat, and it erodes very rapidly from underneath as well as jet impingement, and you lose quite a bit of the seal. We lost most of the seal, in fact. But the nozzle seal is very good, the secondary seal, because it's around the corner and expands, goes down around the corner and eroded some of the secondary seal. We ran a lot of analysis after that because that was the first time that we had observed erosion of a primary seal. We developed our models to predict the erosion, what would happen in blow-by erosion, and it was because of that that we found that hardware, and it was late in June, it was into July that we got all that data together. We went down to Marshall and had very detailed reviews because that was of serious concern to everyone. We had violated the primary seal. It was in the nozzle joint. That we were asked to come to Washington, the headquarters, and review that. It was a very serious concern. It was that time that I got with the engineering people and said, we need to not only put that whole story together, we need to put the whole story together on all the pressure seals, because I and several others still felt that even though that problem happened with the nozzle, the field joint was a more serious concern. Because I felt very good about the secondary seal in the nozzle. I didn't with the field joint. And I put together a presentation for August that I think showed where our real concerns were and why we felt the highest priority was the field joint, even though we just experienced that problem with the nozzle. We felt we had corrected the problem with the nozzle because all subsequent flights had the 200 psi leak check so that we could not miss a possible defective seal or contamination that may have prevented that seal from sealing in the first place. But that was some of the background that I think really turned up the game on the whole seal issue from about April, really in June on. Prior to that time, we were doing a lot of work to better understand this rotation business and all. But we have done a tremendous amount of work. In fact, you may have read in the press, and it's true, that we actually went to a SAE conference last fall. A couple of our top engineers went there to try to get help from the whole seal industry and the SAEs about the field joint. Is there a better way to seal that joint? Is there the Society of Automotive Engineers? And we did a lot of work to try to get help from the outside as well as do the work that we had inside. And I think that's all relevant to the discussion.
Were you surprised that some of the top people in the decision-making process didn't know about this at all?
Didn't know about the CIL or the Criticality 1 or what?
Well, the whole thing, the concern on your part and on the part of Thiokol engineers that the original decision had been not to launch, and all of that.
I'm very surprised at that. I hardly believe that. The issue was so controversial, I thought that I'm sure that they were aware of that. I have a hard time believing they didn't.
Could I ask one question? In talking about Criticality 1 going to 1R, I think you made the comment that you'd have to have all of the tolerances going in the wrong direction to meet that condition. But you did say that one unit did meet that condition.
Yes, best of my knowledge, and I had some record search done, that I was told that there was a condition in the, I think it was forward field joint of the STS-4 someplace that was in that condition.
What if that launch had been done at a cold temperature? Wouldn't it have maybe taken it over the edge?
I don't know. It's possible. I certainly don't feel good about that. But
the reason I asked the question, it seemed to me that if it was a Criticality 1 item, then everybody should treat it as Criticality 1 and not rationalize that it may not ever happen.
Well, I agree with that.
Do you think everybody else agrees with that?
Well, I think, yes, our engineering people agreed with that, and that's why the recommendation we had made originally was the basis for that recommendation. We felt that we had observed a condition a year earlier that we did feel was attributed to temperature in some way or another, and it was not a good condition, and we didn't want to go much beyond that because even though that one was successful, it certainly wasn't a good condition.
Mr. McDonald, was it at NASA's, was it NASA or Thiokol that originally initiated the change from Criticality 1R to Criticality 1 for the primary O-ring?
I'll have to tell you based on what I was told, because I wasn't involved in that change, but I was told that that was NASA initiated. But
what experience led to that change? Do you know?
I'm not sure of what experience led to the change. I presume it was the understanding from the joint rotation data and the drawing tolerances of all these parts that that condition could exist someplace in the hardware, and therefore if we were going to fly the hardware as it was designed, that either through refurbishment or new hardware that was within those tolerances may be matched together sometime to give us a condition like that. But I think you'd have to ask the people that were involved in that particular decision.
How do you account for what appears to be the fact that between December 82 and the middle of 85, when Thiokol became concerned about the erosion of the blow-by, that flights did not occur seemingly during that time that led to the same concern?
Well, I can't explain that. I certainly didn't know about it until August 8th. I don't know. I think that everyone was concerned, at least from the standpoint that we always had to present data on the joints that we were mating to show we had adequate squeeze and all. That data was presented, and I'm sure people were concerned about that.
Thank you.
If there are no other questions, we'll have a 10-minute recess.
And there it is. I don't really have any sort of sage follow-up to McDonald's testimony, other than to say that I found it to be pretty remarkable. It seems to me that it's about as close as we can ever get to a proper recording of the actual teleconference the night before Challenger's launch. Is it possible that McDonald is embellishing points or omitting data that makes him look bad? Of course, and he'd have plenty incentive to do so. But based on the testimony of others, notes he took at the time, and cross-checks with other documents and what actually happened, I think he's telling the truth. If you'd like to hear more from Allan McDonald, he wrote a great book called Truth, Lies, and O-Rings, which I found particularly useful for learning more about the teleconference itself, as well as what life was like at Morton Thiokol leading up to the accident. So if this giant episode wasn't enough, now you know where to find more. Ad Astra. Catch you on the next pass.